Work it, make it, do it, makes us.
So I'll start talking while people kind of still funnel in. So welcome to our talk on Securing Microservices, a Practical Guide. Thank you so much for coming. It's great to see so many people here, especially because I know that there's a lot of other really good talks on as well at this time, so thanks so much for coming. I'm Kate Stanley, and this is Adam Pilkington, and our topic today is Securing Microservices.
Yeah, hi everybody, Adam Pilkington. Myself and Kate both work down at the IBM labs at Hursley, just outside Winchester. And we've been lucky enough to both work on Web to Liberty and something called GameOn, which is an open source project that's going to form the sort of the core part of our experiences that we want to share with you today about the practical aspects of securing microservices. I mean, one of the things we found when we started doing sort of our first forays into microservices a couple of years ago was that there was a fair amount of sort of theoretical talking and articles about the security side of microservices, possibly a simple hello world microservice at the end, but there wasn't any real practical, actually, this is what the code looks like. Me as a developer, this is what you're going to have to deal with, this is what you have to do. I'm not a security person, Kate's not a security person, but we now have to do security. So the idea here is we can actually share with you what we've done in terms of this very practical orientated developer aspect of security. So first off, I'm just going to do a little level set on what are microservices. I mean, a quick show of hands in the room. Who knows what microservices are? Yeah, oh, good show of hands. Okay, right. Who's using microservices? Lots of people talk about microservices. In fact, the joke is everyone's talking about microservices. But yeah, there's a fair number in there. But some haven't. So what we're going to do is we're just going to level set on what we mean by microservice, and particularly how it's changed the security landscape somewhat for a developer. So, having a nice little picture. So what we've got with microservices is, you know, we typically, the word micro implies a small thing. So what we mean by a microservice is something that's small in scope. It's going to do one function. It's going to do one function well. It's a shopping cart. It's a ratings app. It's my list management service. It's something that's small scoped, but not necessarily small. I mean, anyone who's actually tried to, you know, deploy a EE application into the cloud, for example, we know there's an awful lot of scaffolding that goes around one class with, say, 3 or 4 REST endpoints in there. So it's small in scope, but not necessarily in terms of footprint on disk. But they are independently deployed. Okay, I mean, one of the things about why people want to go to microservices is because they're having problems with either the time it takes to deploy the monolithic app, they want to use technologies that aren't available in their chosen language, so they want to be able to deploy these microservices separately and independently. And you know, in the days of the monolith, if you're trying to deploy an app and it takes 3 or 4 days to deploy it, or even months or weeks to go through a cycle, you go to microservices, you can spin up these things and redeploy them with continuous integration and builds as well. They are replaceable as well, so they tend to be scalable. They are stateless in some ways and not in others. So normally they need some data to work. But what happens is they are written to be stateless and they have config injected, or they go and get their state from a backend service. But they are replaceable. You scale them up in numbers. If one gets sick, you get rid of it. They are sort of interchangeable units of work. And finally, they are deployed normally as processes. So they're built around a process boundary. So you typically, the model we've gone for in GameOn is we have one app server that's running one service that's an independently deployable service. The other thing is that they're now, you know, these microservices are communicating across language agnostic APIs. So we have typically, you know, a favorite combination of REST calls using JSON, passing it over HTTP. I mean, it's one of the things that's enabled microservices to take off is it's now you don't have to have a specific library and a specific language to be able to do something. Language agnostic APIs let you create microservices really easy and get them all communicating with each other. So synchronous calls with REST. We have a version of synchronous calls with WebSockets, so long-running conversations. And you can have pub-sub events as well, so asynchronous communication. And we use all of those inside GameOn as well, and we'll show you where they fit in later on. Okay, I mean, another thing that's changing, so microservices have come up and they've changed the landscape. So another quick question for the audience. Who remembers J2EE, the old Java? Oh, I'm in great company. I thought I was going to be the only one. Kate, you'll have to Google that later on, what J2E is. Okay, so yeah, 15 years ago, I wasn't working at IBM. I was in a financial services company. I was a Java architect. I'd done my Sun certified architect exams, the one that a real person actually marked, rather than just cramming for the test, that just AAB and, multiple choice, £100 later, thank you very much. So as part of that, there was very much this sort of, this model was in fashion then. You had middleware, a middleware bundle, and you developed your application. And even in the framework at that point, one of the things I remember them sort of saying was, okay, you're a developer, you just look at your development things. You're a developer. When you've finished, you hand it out to the ops guys, and they deploy it for you. And the ops guys were normally some sort of strange people over the side who did networking stuff and other things. And I wrote my servlet, and I just checked check this user in this role or whatever, and that was my job done. And literally, it was throw it over the wall to the ops guy. He'd pick it up, go, what the hell? And he'd try and make some sense of it, wiring some databases or whatever. But, it was almost sort of baked in at that point that there was this sort of split. Microservices bring DevOps back together. You don't have a DevOps, a development and operations side anymore. You are DevOps. You own the service. It's your service. So you are doing the whole cycle. At which point it also now means that you're having to handle the security aspects. You no longer was it I could just throw it over the wall and let someone else wire it into my backend LDAP server or something else. You now have to deal with the security aspects of it, which is a bit different. So this breakdown from traditional sort of monolithic middleware applications into microservice one has now forced developers to become more exposed to security than they have done in the past. The other thing is that as we move over there, we also bring in the cloud as well. It's not in that diagram, but as we move some of these microservices and we move them off-prem, suddenly, we don't have the luxury of a central authentication system anymore. Other people want to communicate with us in other ways. So the cloud has changed the way we also think about security.
Okay, so I'm now going to give a bit of an introduction to GameOn. We mentioned at the beginning that we've been building this microservice application called GameOn, and that was the thing we were looking to secure. So we're going to use that throughout the presentation to kind of give you kind of real examples. So first, I'll introduce you to what it is. So it's a text-based adventure game. Looks a little bit like this. I myself, growing up, didn't play text-based adventure games. They were a little bit before my time. But hopefully a lot of you in the audience will be kind of familiar with them. The reason we built it is because microservices were starting to kind of become more widely used. People were trying to learn about them and start making not just sample microservices, but do them in production as well. And what we found was that there were plenty of sort of articles and blog posts and things where you could go and follow some steps to build up your first microservice and stand it up. But actually, that one microservice was pretty simple. Maybe it didn't even really count quite as a microservice, just one application running. And when you want to make the leap to then starting doing microservices in production, it's quite a big leap. And there's all these other things you suddenly need to care about around how do I do communication? How do I do security? All these things that you haven't really thought about before. And so what we wanted was to provide people with a way to kind of not have to make that giant leap, but to build everything they know a bit more gradually. So that was kind of the aim behind creating GameOn. So as I said, it's a text-based adventure game, so we've already stood up the main sort of infrastructure for the game, and you guys as developers will come along and write one room for the game. And that is your first microservice, and you plug it into our existing architecture and build it as part of our existing microservice. But then once you have one room, you can start expanding it in different ways. So you could start by just scaling up the one room and looking at what does that mean. Does that mean I need to add some sort of persistence? You could look at extending your room by adding extra microservices that you own. So when someone enters the first room, they then have access to all your other rooms that you sort of manage. There's various different ways that you can go, but the aim was basically that you can come and write a room and then gradually expand your microservice knowledge. So that's why we built GameOn. It's all open source. We'll put up some links at the end if you want to come and build rooms. But for now, I walked too close to you.
Yeah,
Can you still hear me? We turn the mic off. So I'm going to give a bit of a demo of GameOn, and the reason for doing this is because we want to show you kind of, got waving at the back, walk this way, him walk. Do you want to go over there? Maybe you're too close to the speaker. So I'm going to do a demo of GameOn. The reason for this is because we want to talk about security, so we're going to show you kind of an example flow to then be able to talk about how we secure it. So this is GameOn itself running, and I can just click enter here, and I've got some sort of sign-in, so we're already starting to see some security here. I'm going to choose GitHub, and that's taking me through saying, want to log in with GitHub. So, not used to this keyboard. So I'm going to log in. Hopefully that is the right password. Yep. And we're into GameOn. So I've already logged in before. It would normally ask me for sort of my name and things like that, but it already knows who I am. And this is GameOn itself. I'm arrived in the rec room. I can say help, and it gives me some information. And I can also move, so I can say go north. And currently the information here on the screen is coming from one of our internal services that we stand up for you to have a first room to go into. But if I go north, I change into a different room. And this different room, then the content is being served somewhere else. I also have some options at the top. I can go and I can change my player information, so I can update my name. I can update my favorite color, because we decided that when you play GameOn, you should have your favorite color as part of your user. And then also you can update any rooms that you've created. So if I go back south to the rec room, and then I say list my rooms. Oh, apparently it doesn't know how to do that. Well, theoretically, I should be able to list whatever rooms I have. And I can then go and update them as well. So that's just a little show of how it works. If I switch back to the slides. So what does that look like in the GameOn architecture? So this is our architecture currently. So I'm going to kind of talk through the flow I just did and how it relates to this diagram here. So the static service is serving up all of our static content for the front end. So when I'm logging in, that's the information I see. When I actually do the login, we're talking to the auth service. We'll talk more about that later. And then when I do different actions, I'm then communicating and working with the other services. So the mediator on the end mediates between myself, the user, and the rooms that other people have provided. So when I moved rooms, it was the mediator that was facilitating that move. And the original room that I landed up in is served by mediator as well. Then when I wanted to update my player's name, I interact with the player service, because that deals with all the player information. And then finally, if I want to update the name of a room that I've registered or change something about that room, then I can interact with the maps service. And you'll notice there's a couple of other boxes there at the bottom, so that's some other sort of services outside of our core infrastructure that we use as part of GameOn.
Okay, so when we were, so we were showing you how we were building GameOn, and we were letting you come in and register rooms, and we want players to come in, and we have some fundamental questions that you want to know, particularly when you're standing up a public service like GameOn, where we've let other people from outside our organization join into our infrastructure. We want to know sort of, who are you? So, we saw the social sign-on, we'll cover that in a minute. But we want to know, do I trust you? Okay, so I know who you are, but do I trust the information you're giving me? Are you a trusted party? And have you changed anything along the route? So, like 3 fundamental questions that sort of, you sat there, you have a REST endpoint, and you have a set of questions. Is who are you? Okay, I know who you are now, but do I trust you? Are you in my circle of trust? And more, importantly, have you changed anything? I mean, some of these microservice interactions, go through 3 or 4 microservices down the way. You don't have a user in front anymore. You have services talking to each other. And it's important to know whether, for example, it's coming down. Forget GameOn, but I mean, if you think of a banking system, for example, and you have a debit amount or a credit amount going through a series of microservices. You don't want someone changing that from £10 to £100 halfway through and then just passing that along and going, hey, that's fine, and you end up with £100 coming out of your account instead of £10. So there are various issues about not just who you are now, but there's the service interactions and, as I say, data integrity questions. So let's look at who are you first. So we've gone through this with our social sign-on. I mean, traditionally in the enterprise, remember back to that monolith, you had a central enterprise server, and that would manage your usernames, your roles, what groups you were in. But when you come to GameOn and when you come to letting other people in, we had a choice. We could sit there and manage our own usernames and passwords and the revocation of that. But you guys, people coming into our system, don't want to have to create yet another username, yet another password. So we implemented the social sign-on factors. Now, lots of these have libraries. They're a lot better now than they were when we started doing this several years ago. And the code in there actually goes through and lets you authenticate through one of the social sign-ons. Now, what they do is they all work in approximately the same way. And one of the things we found is we had to go through and work out a few nuances in this flow as we're going through. So now you can get a library, or you can have a service or whatever does a lot of this for you. But as developers, we also wanted to know what went on under the covers. It's great, using a library, but actually what happens under the covers. So prior to any of this happening, prior to even offering you some form of login, what we need to do is we had to go and register with Google or Facebook or Twitter or GitHub. And they give you, as part of that registration process, some pieces of information. Typically, one is a public bit that you can share with other people, and another piece is a private piece that you keep to yourself. So think public-private key, although not necessarily an actual public-private key. It depends on the organization. Okay, so that's happened sometime in the past. You come along and you do authentication. So what happens is the client comes in and makes that request to access a page, and you need to log in. So you redirect them for authorization. And what you do as part of that is you give them that public part that you got from, we'll stick with Google for a minute, so save them all of them, that Google gave us when we registered for our account. We pass that back to the client, and a redirection off to the Google server that says, please go and log in over there and take this piece of information that identifies GameOn, which is why it said GameOn is asking for your information, because the client browser redirects to the third-party site. It looks up the public thing that was passed in, knows it's GameOn text, puts it up there and says, okay, here's the roles that GameOn is asking for. Sign in, grant the roles. So you log in, redirects you back, the browser back, and then that redirects you back into GameOn. Okay, so far so good. And as part of that, we have an opaque blob come back. So it transfers back from the third party via the browser and then back up to GameOn again. So it's all bouncing around over the systems. And we'll come over to where some of the things you've got to watch is that, of course, it is going via the public. And anything that goes to the client should not be trusted. Okay, as a general rule, anything that goes to the client and you receive back can't be trusted. So, but in this case, we have a blob come back. We take that blob, we then give it back to Google along with our private part of the information they gave us with the registration. They decode it and they give that information back to us and say, yes, this is this person and this user, and these are the roles that they've allowed you to have access to. So that's how this flow works. And let's say and then what we do is we create a JSON web token, which we'll come on to more details about how we use the JSON web tokens with that information. And then we manipulate that and we pass that around the system. So as I say, one of the key things we get asked about is that secure? As I say, it is secure because we are allowed to give out that public part. That doesn't matter. That just identifies us to Google. The information that comes back, the client can't read because we need to provide the private part of it back up to Google on the back end. So you see how the whole system hangs together such that we can actually offer a secure sign-on. We as GameOn people, we never see your username, your password, but we know who you are. And you as people can log in with your favorite account and you don't have to remember 600 different usernames and passwords to get into different systems. So just a reminder, this was our back-end system that's going on that Kate explained a minute ago for the system. And this is all happening in the auth service here. So originally it was all bound up in one. And I think we had one provider. And then we realized quickly we needed to provide more logins, more ways. So we split that out into its own microservice. Yeah, it became big enough, yet scoped well enough that we say this was an auth service. Now, as I say, we did this because, one, this is an option. You go to Twitter, you get their client library. Or you go to Google and you get their client library, and I can show you the GitHub repository where those are, but you still have to do some work at that point. And that's if you do it manually. Now, there are services. I mean, we work for IBM, so inside Bluemix there's an AppID service, and that will handle the authentication for you and basically give your service a signed JWT. But I mean, that's by the by. They are just doing the same here. It's just that it saves everyone else having to do the same authentication. So it's almost like the next level of abstraction up, which is, okay, I've taken it out and I now have an auth replaceable. Remember we said these services are replaceable. I can now replace one auth service, the one we wrote, with one provided by our favorite cloud platform provider.
Okay, so the next thing we're going to talk about is JSON Web Tokens. And just going to kind of introduce you to them first and then sort of explain why we need to use them. So they used to carry a representation of some information. As you might guess from the name, the information is in a sort of JSON format, and they contain certain claims about the request. So things like an issuer, a subject, an expiration time, that sort of thing. And the reason we use them is because now that we've gone and got our auth token and we understand something about the user, you know, we've got a token that represents what we think they're allowed to do in our system, we need some way to pass that around. And we use JSON Web Tokens to do that. So a JSON Web Token will help us to make sure that the request was initiated from a specific user request, and then also know the identity of that user and what they're actually allowed to do. There are 3 time-related fields that you can then include in your JSON Web Token, and these are things that you should be verifying as you pass your JSON Web Token around. The first one is IAT, so time that it was created, the not processed before time, so when you should not process it before, and then the expiration time. And you should be validating each of these dependent on what they are. So time JSON Web Token was created, make sure that's before the time you receive the request. Expiration time should be after, not processed before, should be in the past. So those are the kind of 3 time-related fields that you should be verifying, because then when you pass your token around, then there's some understanding of, yeah, we think this looks like a valid request. The other thing to note about the expiration time is that could be useful for checking if you've seen this request before. If you have your expiration time to be reasonably short, then there's a reduced chance of replays happening. So we've now got a way to pass our information around, and we can say, okay, next service, here's the user, and this is what they can do. But there's still a risk there, because we're passing information over a request. It could be tampered with as it goes through. And that's where JSON Web Signature comes in. So you take your JSON Web Token that you've created from your auth token that you got from OAuth a minute ago, and you sign it. And there are 2 ways that you can do this. You can use a shared secret, so that's symmetric signing, or you can use a public-private key pair, so asymmetric. With a shared secret, the idea is that you share the secret that you're signing, so you need to be careful who you're going to give that secret to. If you give it to just anyone, then that means just anyone can create new requests that your system will view to be valid requests. So there's a risk factor there of who you give that shared secret to. With a public-private key pair, you give the public part away and you keep the private part to yourself. If you give away the private part, then again, people can create requests that you would then validate as being absolutely fine, and there's a risk factor there. So with public-private key, you can give away the public key, but you want to keep the private key to yourself. And you'll then be using the private key to validate the request when it comes back in. So that's a bit of information about what they are more generally, but how are we using them for GameOn? So as we said in our flow earlier, we've logged the user in, and now the user wants to make some sort of request. So that's where the JSON Web Token comes in, because it carries a representation of that person, and we need that to be able to work out if they can make the request that they want to make. So for example, if I'm a player in GameOn, I can't make a request to update Adam's user information. I can only update my own user information. So we're using the OAuth access token that we got from your social sign-on to create the signed JWT, and then we're signing it with the GameOn text.org certificate. The reason we chose to use our SSL certificate is because it makes it easier from our point of view. We already have a well-known public key, and we don't have to set up a new public-private key pair and manage it in that way. We can just use the one that we have. So we sign it with the key, and then we pass that around. So that's what we're using whenever we've got interactions between different services within GameOn, because they can validate with their private key that each of the services gets injected to make sure that they trust that the JWT that's come over hasn't been tampered with and has come from someone that we kind of trust. So we've got some code here. Example, as I mentioned earlier, GameOn is open source. You can find it on GitHub. This is a slightly shrink down version of the code, just so that it would all fit on one slide. But if you want to go and look at it in more depth, then feel free, we'll put up the links all at the end. So the things I just want to call out here is you can see we're setting some claims here at the top. So things like the subject, the audience, when it was issued, the expiration, and then also we're then signing it, and we're signing it with the private key. So then when you validate the JWT, you then validate against the public key. Now, the other thing to note here is actually we're using a library here. We're using the Java JWT library. If you want a link to that, then again, you can come up at the end and I'll give you a link. But it's useful to use libraries wherever possible, because if you use a well-known library, then there's a better chance that more people will have used it, and it's kind of a bit easier to trust, rather than trying to kind of roll your own, especially if you're fairly new to security. So that's how we're using JWTs in GameOn at the moment. It's the service-to-service calls, so that we know if a particular user can make the request that they can make, and that the information about that user hasn't changed in transit.
Okay, so before I go on to has anything changed, I mean, just to carry on with the JWTs, if I go back to my flow here, I mean, one thing about passing this signed JWT on, now that we know that this means that we know who that user is, and because we sign all that data in the JWT, we know it hasn't been changed. We can give that to the client, which allows long, interactive sessions. So someone to come into GameOn in one room and then go away, come back 2 hours later. They can represent the same JWT to us, and we know, because we can validate the signature, that they haven't changed anything. So we let those things live for about a day before we expire them. But it means that in sort of long-running processes, or particularly where you're going to have users come and go, you don't have to get them to re-authenticate every time. You can give them an authentication period at that point, and you can be confident that they haven't changed anything because you can validate that none of the JSON has changed. Now, interestingly, we found as a little tip that when we also, particularly when we're interacting with GitHub, as part of the actual logging on and requesting permissions, a lot of these libraries allow you to pass a bucket of stuff, should we call it. It's normally a tag field or something else on the end, which is sort of stuff. And you can pass that up to GitHub, and GitHub, as part of its authentication, will basically pass that information back to you when we do that decoding on the back end. Now, the thing is, you still have the same trust issues at that point, is that, okay, I know it's GitHub, but I really shouldn't trust that perhaps, whatever comes back round again is what I actually sent out to the client in the first place. So the technique we found was to actually put a signed JWT as in that bucket. You can then send that up, and because in the async world it comes back on a completely different thread, that's absolutely fine, because we know we signed that data, GitHub didn't change it, we can action it. So although we can't put anything in there that shouldn't be shown out to the client, it does mean that we can interact asynchronously across multiple threads and multiple services, being sure that what we got back is what we sent. And this allows us to say things like, so for another thing we do, which is a code accelerator called App Accelerator, you can automatically have the code pushed into GitHub for you. Those permissions, and that has to be handled in that async, because the callback we get is on a completely different thread somewhere else that had no idea what data and what user was logged in. But because we receive back the signed JWT, we can trust that, we trust ourselves, and we can carry on doing it. So there are some interesting things you can do with JWTs beyond sort of, you just using that as an easily parsable data format. But you can, as long as you don't mind sharing the data, it's really useful to be able to say, has that changed, and getting it back at a later point in time. So again, the app accelerator stuff is another microservice-based thing. So you have this same issue. It doesn't matter what instance processes it, you can validate it. So, I mean, these JWTs, so they allow us to establish, who you are, and once we know who you are, we have covered an aspect of has anything changed with the signature. But there is another way of doing it, which is this message authentication code, or hash message HMAC. And this is more where, you remember in the architecture diagram, you have services communicating with other services. That's not it. That's not who you are anymore. That's this service. That's the mediator service talking to the room service. The who part isn't a person anymore. It's a service. And you want to be sure that that they haven't, that you trust that person. So you want to make sure with this HMAC that you authenticate the service, and again that the contents haven't changed as the flows come through. So how do they do it? So in GameOn, the service operations is a shared secret, and that enables us to establish trust because we share a secret. It's a bit sort of, sometimes it's a bit hard to understand, but yeah, I trust you because you know a piece of information that I share with you. That's how I trust you as a service. So when you apply it to the HMAC and you encode with it, then and I decode it, we share the secret. Now, of course, you have the problem with the secret. Anyone else who finds out that secret can become a trusted service. But it does allow you to establish a service-to-service identity. Now, the other thing about when we do HMAC, so HMAC is normally a sort of quite a convoluted process. You can make it as complicated as you want, but if you look in the GameOn documentation, what we do is we do things like we take the creation date field of the HTTP header, we do things like hash the body, and so we end up with a hash. We hash the query string parameters. We hash your GameOn ID, and we put all those together into the HMAC, and that basically put together with the shared secret, and you end up with basically, and then base64 encode it. You end up with a string, okay? And then we put that in an HTTP header. We send out to the thing we're connecting to. Basically, the thing about, and as Kate's saying with shared libraries, one of the reasons you want to use them is that you don't have to reverse that process to unpack it all and to establish that nothing has changed, because basically you don't trust what you're given. You repeat the process at the other end to make sure you get the same answers as you've been given. You don't trust what you've been given. Remember that. That's the rule. We never trust what we're given. We go through and replay. So I have to sit there and rehash the body, do everything else. And the problem is that if you have two people doing that, then the problem is that it's very easy to make a mistake in that hashing, and then you start rejecting things false rejections. So what we did in GameOn, and we've created, we've extracted our own library because we wanted to make sure that people could successfully register rooms. We extracted our own library, and it's now a shared library that we then inject into other microservices. And we follow good 12-factor application coding. It is its own code base, and we use something called Jetpack. Has anyone heard of Jetpack? Anyone using Jetpack? No? Blimey. Okay. Jetpack is really good. So Jetpack.io lets you point it at Jetpack at a GitHub repository, and you can declare a dependency in your Maven or Gradle file, and it will resolve that dependency through Jetpack with whatever the release is that it wants to pull from GitHub. So it makes anything. So even if no one has released a jar into Maven Central, you can use Jetpack to point at their GitHub repository at a release in there, and then write it as a dependency in your build file. So we can just put all of our shared signing code into this one repository. We then put a dependency in the build file that says resolve from the Jetpack repository our name and version, and basically it runs through Jetpack, and Jetpack pulls through the code and injects it in with all the dependencies we need as well, and manages all that for you. So it's a really good way of actually sharing those sorts of cross-cutting concern libraries, like where security is one of them. The other thing about HMACs is, compared to JWTs, they're very small. Okay, JWT is JSON. HMACs comes out with whatever it is, 128 bit string bits that's converted into a representable string. What that means is then, because it's passed in HTTP headers, you can actually action it before you even get to processing the body. So with the JSON one, you'd have to go through, you'd have to parse the JSON, do the signature. The HMAC, we can validate it in the header. Now, that lets you do some clever things with WebSocket handshakes, for example. So as part of the WebSocket handshake between our mediator and the room, we HMAC that when we call the room. So what the room can do is it compare the shared secret and do the HMAC processing. And if at any point it fails, it can reject at the WebSocket handshake level, so you don't even get a connection made. So it allows you to action and route based on header information rather than actually taking a body and parsing the JWT. Now, of course, yeah, you could cram a JWT into a header, but it becomes much simpler to do it with just HMACing by the header. So there are sort of different things. It's as I say, slightly more complicated, but has better uses in terms of faster processing. Okay, so sort of we'll talk a bit about development versus production, because I mean that's always something that's tricky with security, is that you want parity between your development and production environments, but that's hard to achieve because it's security. You know, a lot of things should only be known to the production environment, and so how do we actually let you develop locally? I mean, one of the really good things about GameOn, and we took great pains to be able to achieve, and we'd like to share some of that pain with you right now, is how to actually, you can stand the whole thing up locally. All that infrastructure you store, including even the Kafka and the CouchDB, if you clone out of our Git repository and run some shell scripts, you will end up with whatever it is, 10, 11 Docker containers, all running the services, and the whole thing runs completely locally. So in order to do that, we had to address a couple of issues. And one of the things we saw was that bit about accessing third-party services. So, okay, we ended up with having, you know, we went to Google, we got our development key. But now how do we actually get that, you know, into the system? So in the production system, that's actually injected as part of the build pipeline. And we use a service called etcd, which is a name value key store service. And that lets us get together and sort of basically, if any of you have seen in the build pipeline, you go through and you define your environment variables. And we actually, instead of filling out each one, we just have them filled in from etcd. But basically, the thing is, we inject the real stuff in the build pipeline. Okay, the things we can't share anywhere else, the things we don't check into the GitHub repository. But it does mean locally, when you run it locally, you do get an anonymous login box turn up inside GameOn. So that's how we've done it. So when you're running locally, it works out it's running locally, and it presents you with anonymous users, so you don't actually get the social sign-on. But you still get a JWT signed. I can't remember, I think we dummy up the back-end provider, so we all trust it. So everything else flows. The JWTs are still signed. We don't do anything differently. It's just that you don't have to go through the social sign-on. So we've gone through and providing it. But it's one thing about when you're looking at these systems is how you are going to work out your own development versus production parity.
Okay, so we're kind of there. So I think we've kind of hopefully taken you on a journey of how we created GameOn and specifically then secured it. So we talked a little bit about how we do our social sign-on, how we propagate who the user is, but more specifically what the user can do through the system to make sure that each microservice, when it receives a request, knows if that particular user can perform the function that they want. And then finally, we've talked about how we understand and trust that when requests come into a service, it's a request that's been made by another service that we trust, and that the information, whether that be the information about the user and the claims in the JSON Web Token, or more generally the actual content of the request, the body of the request, we make sure that that hasn't been changed. So these are some points that we kind of want you to go away with. When you're moving to microservices, that means you're going to have more interactions. And this is the place where security is something that perhaps you haven't had to think about quite as much before, and is definitely a good place to start when you're looking at how do I secure my microservice. And it's important that you understand the interactions between the different services and look at what is the risk here. For example, when we're doing things with a room, when our services talk to a room, they use a HMAC and we have a shared secret. And we just share that secret between GameOn itself and that particular user who has the room. And that way we know only those two people have the shared secret. And if they want to create more requests, they'll just be doing something with their room that they already own. So it's kind of understanding what are the risks in that particular interaction, and then what can I do to address it. So that comes into the second point, which is understanding the concerns. For each interaction, who are you? Do I trust you? and has anything changed as things have been passed between the services, which is particularly important when you have a chain of interactions. They might have gone through several services to get there. The third one is to centralize using common services or libraries. So we've talked about two examples here. One of them is our auth service. So we put that there to make sure that if we wanted to change the way we were doing social sign-on, then we just change one service. And it means that all of the other services are actually, they have no clue how we do our authentication, and they don't need to. The other interesting point, which I don't know if we mentioned, but if we wanted to add more front ends as well, they can interact with the auth service. We don't have to have different authentication in the different front ends. They're all oblivious to how we do authentication as well. And then, of course, the second one was the shared library, which Adam talked about. The very last thing is do it early. This is something that I think with security and I guess with microservices in general, there's so much to learn. There's so many things that you could do first. But I really think that when you're doing security with microservices, you should be thinking about it right from when you write that first service. Because as you build up your microservice, you'll be talking about what are the interactions, what does this mean here, and you may as well add into that conversation, what does this mean for security, should we be doing something here for security. With GameOn, we did think about it from the beginning, but there's definitely more we could have done from the beginning, and as Adam said, we had to refactor and take out the auth service, which was actually fine because we built it in a modular fashion. We didn't have all of the auth code sort of trickled into everywhere. It was quite contained. So then when we decided to split it, it made it easier. So even if you don't start off with a separate service or a separate library, if you build security in from the beginning and build in thinking about how your microservice is going to evolve, it will make your life easier as you go forward.
So just before we finish off, I'll show you where you can find this stuff on GitHub. So first off, there is a Git book, which has all of the information that we've gone through on there, or certainly a sort of guides and how-tos of how things are on there. And if we look down here, there is the section on application security, and it talks about how we're doing the request, talks about how we're doing the OpenID authentication, the signed requests. So, for example, here are the headers we're doing, because you have to document it. So we want people to come along and they've got to be able to implement this. Use our shared library by all means, but we do document fully how we construct it, particularly when it comes to the HMAC. So if you look down here, just to run through, we sort of initialize it. We put in the method, the request URI, your GameOn ID, the date, the headers, all of the other HTTP headers, all of the other parameters, and all the body, and we make a hash out of that and then encrypt it with your shared secret. The other end, you decrypt it. The decryption works. The shared secrets are good. Therefore, I trust you. And then I can go back and make sure all the hashes. So this stops you actually changing anything. But you can see how easy that is to get it wrong when you're going through, or do it slightly out of order in a slightly different way, or you've got a slightly different date format or something else. So that's why we quickly standardize on the library. But how we did it all is all in here with examples, so you can test yourself about what you should get out in there and how to parse it all the way back again. And particularly also how to do the WebSocket handshake. So, as I say, it's interesting if you've never got into the actual depths of the WebSocket handshake, how you can actually influence it and reject it before it even gets upgraded to a WebSocket connection itself from an HTTP request. So this is the actual GameOn GitHub repository. So down there, and as you can see, there's it's actively developing. We're still working on this. New code is going in. It's not something we've finished with yet. Microservices and everything else is still continue to evolve, and we'll continue to work on it. We have the Swagger in there. We have also rooms in different languages. So for non-Java developers, we've got a Swift room, a JavaScript Node room. These people are all trying out microservices, and you'll find the HMAC implementations and the signed JWT stuff in those languages as well, because remember, these are cross-language, cross-cutting concerns. Just quickly, so here's our auth one, and as you can see here, so you can look in here and see how to do Facebook, GitHub, Google, Twitter authentication. Code's all in there, have a look. This is the actual shared library, so you can see how we actually do the sign request, how we intercept, how we do things like that. And one of the cool things about our shared library is it's annotation based. So you can take a simple JaxRS class, add one thing, go, that's a signed request. Ooh, suddenly it's HMAC'd. Suddenly now it has to be secure coming through. Didn't change anything. You don't want it, take the annotation off. So there are lots of things in there about how, we evolved from having it, in a class to then into a shared library to then annotation and CDI injection, all sorts of other things on top. So we evolved it as we found that once we'd actually worked out how to do it, we needed to keep doing it in different places and make it consistent. And finally, in the mediator, I've just pulled out an example of an API key in here. Haven't really talked about API keys. They're just more of a sort of a bearer token. If you have a key and you present it, we'll just check it against a list of keys that we've got. So, it's very straightforward, but we've just left that out of sort of the more complicated things that you get asked to do rather than, did you give me, this value in this field? So I think we've got about 5 minutes left. So are there any questions?
Have we got a microphone?
Is there a roving mic?
We're just trying to shout.
A guy called Mike who's going to rove. I'll sort of come here and try and repeat it in here. Oh, no, I think we've got a mic coming down.
So if you don't store usernames, you can't sign in with multiple services on the same account. So I couldn't merge my Facebook and GitHub. Could I do that?
So when you say...
So link them so I could decide to log in from either one, or is each...
Okay, so we store just the one that you log in with to give you the ID. And I suspect at the moment we would treat you as separate people when you're logging in. But we are, for what we've done here, we just want to validate that you are who you say you are because GitHub or Facebook said that's who you are. And, primarily to, I think in GameOn, to get your email address, for example. And like that. So, I'm not sure how you would merge up an identity. We just need to know from one of our trusted authenticity providers in the social age, one of those people, that you are who you say you are.
Yeah, the key aim was to be able to say this user can do these actions. And so we haven't linked them up. So I know I have rooms that are deployed under my GitHub and under my Google because I forgot which one I signed in with.
So, I mean, we could go in and we could say, okay, so if you sign in and, bounce you back through the other one to check that you are, who you say on the other one at the back-end storage, then we can put the two together and say, whichever one you log in, when you do want to go and work on your room and change the description or register a new room, you could use either one. I mean, that's almost implementation detail at that point. The fun part, shall we say, is getting the Twitter thing to work in the first place, whichever way they've done it, because they're all, of course, slightly different, but the main concept is the same.
I have a follow-up question, which is just, are you using any of the stuff inside IBM for any, was this the launch for Paradigm, best practices to use in actual products?
So all of the core services are running on Liberty, which is got our cool Liberty t-shirts if you want to get one. I think they have them at the IBM stand. So they're running on Liberty and on Bluemix, mostly because as a team, that's what we were doing at the time. We were working on Liberty and looking at how do you do microservices with Liberty, how would it work? So quite a few of the services, like we're using Amalgamate, which is, that's actually open source, but was kind of created by people from IBM. So there are quite a few IBM-related things, and you'll see in our templates, a lot of them deploy straight to Bluemix, IBM Bluemix. But the aim was really to help educate people about microservices. We saw a need for our customers. They wanted to know, how do I get started with microservices? And we wanted to give them a way to learn fast. So we're really encouraging people to come and deploy them different ways. When I was at DevOps US earlier this year, we deployed a Wildfly room, for example. So we're keen for people to do them in all different languages and have rooms that are stood up in different clouds as well. But the core services are running on Bluemix currently. Is there any more questions? I think there's one right at the back there.
So when you generate the JSON web token, what is the normal expiry time? So how long is valid for, and what if the token is compromised? And you want to share with all the services?
Okay, so the actual exploitation time in some respects is up to you. There is a trade-off between, forcing someone to re-authenticate and regenerate a new token based on how long you want to trust that token, plus variances, and don't forget we're now in a distributed computing environment, so it's not like just a process call on the same box anymore. It's got to go across a wet piece of string somewhere between two servers, so that may slow it down. So what we did when we did the one there was we did a 5-minute. We picked 5 minutes as a almost arbitrary, we weren't getting anyone rejected, but if something turned up far too late, then we wouldn't honor it. So we arbitrarily picked sort of 5 minutes simply because with distributed computing, for example, when we're calling out to a room that's hosted somewhere, that's probably been hibernated somewhere and it has to come up into life and everything else. So you need to balance that sort of, now that you're in a distributed environment, plus how long it's going to take to continually ask to regenerate tokens as a choice. And the other thing to also do in there, we sort of briefly touched on replay attacks, is actually to store, the ones you've received for a certain amount of time that's linked to that effective time. So if we pick a 5-minute window, then we'll store all the requests we receive in that 5 minutes. Because then if we see a duplicate one come through, we won't honor it, because some of these other systems or other microservices, they may have 2 instances that are sending things to us, which is the same request. So we keep track of everything we receive. And it also means we had a bad experience at one point with one of our things where we managed to register about 1 million rooms into Couch because something just started replaying room registration requests to us. So we put in a thing that said, okay, if we've seen this request before, we won't do it. And you tie it to your timeout for your JSON web token, because if you don't honor anything after 5 minutes, you don't need to keep it. So they link together in terms of other things that you do as part of the security.
I think on the snippet that I showed, the code snippet, it was in comments, but you should always make sure that once you've validated the request, if it's not valid, then do something about that. And what that something is up to you, and it's about looking at what are the risks in this situation, what is going to be the impact to the user if I have to throw an exception or something like that. We've got 1 minute. Does anybody want to ask another question? Cool. Well, the little screen down here has just said time's up, so that's good timing. So thank you very much for coming.
Thank you.